this is Britt Caswell with another example video. In today's video, I'm covering example 5 from lesson 5-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to learn how to solve an equation with two radicals. I gotta tell you, y'all, sometimes looking at these can feel a little overwhelming, okay? So what I'm going to do is I'm going to solve this problem, and then I'm going to walk you guys back through it again, just so you can see kind of the overall big picture of it, okay? Because there's a lot of steps to this, and it's easy to get lost in the weeds, okay? So our first thing that we do is we start by isolating a radical. I know there's two of them. Just pick one and roll with it, okay? I'm going to do this one because it has the plus in there, and I find that I hate addition. And anyway, let's just deal with the ugly one first. So what I'm doing is I'm adding the square root of 2x to each side so that that radical on the left is now alone. Now on the right, I have 3 plus root 2x. Now remember, to get rid of a radical, what you have to do is you have to square it. So I am squaring both sides of the equation. Now on the left-hand side, that cleans up really nice. It just turns into an x plus 9. But on the right-hand side, remember, when you go to square, you have to use that distributive property. So I am actually taking 3 plus root 2x, and I'm multiplying it times itself. So here I'm going to take the 3 and times it to each of those. So 3 times 3 is 9, and 3 times root 2x is 3 root 2x. And I'm doing the same thing with that root 2x. So 3 root 2x is just 3 root 2x, and root 2x times root 2x is just 2x. And you could still combine those middle terms into 6 root 2x, but that right-hand side looks a little uglier. And it's okay that it's a little uglier. We don't judge it for its ugliness. But what we've done is we've taken the equation from having two radicals down to having one radical. And we know how to deal with one radical. You isolate it and then square to get rid of it. So that's my next goal, is to get rid of all this tchotchke that's around the radical so that I could square and remove it, okay? So I know that I need to subtract the 9 and the 2x because they're just sitting out there. So on the left, x minus 2x is negative x, and the 9's cancel. And on the right, I'm left with 6 root 2x. Now that root is still not alone. We still have to get rid of the 6. So remember, if you have a number squished up against this grouping symbol here, that's multiplication. And so to get rid of it, I'm dividing by 6. Alright, so now I'm sitting at negative x divided by 6 equals root 2x. Now notice I'm also out of room on my paper. Oops. So what I'm going to do is create a couple of lines and just pretend like my screen continues downwards. Okay, I'm just going to write it over here. So, to get rid of a radical, what do? We square it, right? So I'm going to raise this to the second power. So on the left-hand side, negative x times negative x is x squared, and 6 squared is 36. And then on the right-hand side, the root and the square cancel out, and I'm left with 2x. Now I know y'all kids, you freak out about fractions, and you're like, oh no, there's a fraction here. That's not hard to get rid of, right? I could just multiply both sides by 36. And suddenly, that's no longer a concern, okay? It turns into x squared equals 72x. Now remember, if you have a quadratic term and a linear term, you are going to need to use the quadratic formula or factoring or completing the square, okay, something like that. You cannot just divide by x, okay? What you're doing is you're removing a potential solution, okay? So don't divide by x here. You need to get everything to one side and in this case I'm going to factor it, okay? So I'm subtracting 72x over. So on the left-hand side, I get x squared minus 72x equals 0. And because there's not a c term, this is actually really easy to factor. I'm just going to factor out the greatest common factor, which is x. So my two potential solutions are 0 from this x or 72 from that x. And those are what we're going to check. So let's start with the 0. So I'm going back to the original equation and plugging in 0. Okay, so 0 plus 9 gives me the square root of 9 here. And 2 times 0 is 0. And the square root of 0 is 0. And subtracting 0 does nothing. So that term we're just going to get rid of and pretend like it never existed, okay? And the square root of 9 is 3. Okay, so if back at this step, if I had just divided by x to remove a solution, we would have lost this answer of 0. And 0 actually worked. So that's why if you have a quadratic and a linear, you need to make sure that you move everything to one side and factor, okay? So now I'm going to check again, but now I'm checking the 72. So I have 72 plus 9, and the square root of 2 times 72, and all that equals 3. So 72 and 9 makes 81. 72 and 2 makes 144. If I take those square roots, this becomes 9 minus 12, which is negative 3. And negative 3 does not equal 3, so 72 is not my answer. The only answer was x equals 0. So let's walk back through and make sure that you understand what we did, okay? So our first step here was to get a radical by itself. And then we squared it to get rid of it. Now remember, when you square, you have to expand, which can be kind of ugly. That's what we did in this black box here. But what that did was that created an equation that had just one radical in it. So we solved for that radical, and then we squared it to get rid of it. And then we knew that we needed to factor, so we put everything equal to 0 and factored. This process looks the same every single time. That's what we're going to be doing. So let's try another one. So step 1, isolate one of the radicals. So this one, we're just going to add root 3x over. Oops. Put your root in the right spot so that it's gone. Okay, so on the left-hand side, I have the square root of x plus 4. And on the right-hand side, I have root 3x minus 2. I just put it in front. It doesn't matter if you put it in the front or the back, and you keep that negative. I just think this looks cleaner, so that's what I did. And again, to get rid of a radical, I'm going to square both sides. So this left-hand side turns into x plus 4. And on this right-hand side, I kind of groan, come to the side, and I'm going to expand that. So I'm going to take the square root of 3x and times it to each of those. So root 3x times root 3x is 3x. And root 3x times negative 2 is negative 2 root 3x. And then I do that same thing with negative 2. So I have negative 2 root 3x, and negative 2 makes a 4. And then combine your like terms like that. So this expression here is what's going to go on the right-hand side here. All right, so now remember, now we have one equation, and on that one equation, we have one radical. So we need to get the radical alone. So now let's get rid of some stuff. I know the 3x has to go, and I know the 4 has to go. So x minus 3x is negative 2x, and my 4's cancel. And here I have negative 4 root 3x. So that negative 4 is multiplying to the 3x. So to get rid of it, or to undo it, I'm going to divide by negative 4. And again, I run out of space, so I'm just going to put a couple of lines. Ooh, jeez. Tell my sticky keys that I don't want to hold down shift for forever. There we go. So when I divide by 4, what that does is this turns it into x over 2 equals the square root of 3x. Okay? So now that that radical's alone, now I have to square both sides, right, to get rid of the radical. So I'm going to square up, yo. That's a bad joke. I publicly apologize for that. So x times x is x squared, and 2 squared is 4. And on this side, the root and the square cancel, leaving me with 3x. We hate fractions. So again, to get rid of the fraction, what do? We multiply that by that denominator. So I'm multiplying both sides by 4. So I get x squared equals 12x. And remember, we can't just cancel an x out here. We have to factor or complete the square, so that 12x is going to get scooted to the side by subtracting it. We're almost there, y'all. I know this is quite a process. Now remember, this is nice to factor, right? There's no c term, so I'm just going to pull an x out. So my possible solutions are 0 and 12, and those are what I'm going to check in my check step. And it might be a long check step, but there it is. So let's start with the 0. I love having answers of 0 because they're so easy to solve. So here 0 plus 4 is 4. Here, that's a square root of 0, and subtracting 0 does nothing, so I just cancel it out. So I get that 2 equals negative 2. So that one's extraneous. Okay, that one doesn't work. So now we're going to try it with the 12. Okay, so I have the square root of 12 plus 4 minus the square root of 3 times 12. And we're going to see if that equals negative 2. So 12 and 4 is 16. 3 and 12 is 36. And if I take those square roots, I get 4 minus 6, which is negative 2. And negative 2 does equal negative 2, so 12 is my solution. All right, one more of these, y'all. We got this. I have faith in you. First step, isolate a radical. So I'm going to go ahead and add the root 6x to each side. So I get the square root of 15 minus x is equal to root 6x minus 3. To get rid of the radical, we square up. So I get 15 minus x equals, and we have to actually do that, which sucks, but there it is. So root 6x times root 6x is 6x. Root 6x times negative 3 is negative 3 root 6x. Negative 3 root 6x, and negative 3 makes a positive 9. Okay, so in terms of this, I get 6x minus 6 root 6x plus 9. Okay, we distributed that 6x fully. You guys didn't know you guys were watching a comedy video, did you? So again, we want to get that radical alone. So to undo that radical, I got to get rid of all this stuff. So I'm going to subtract 6x from each side. I'm going to subtract 9 from each side. Okay, so here I get 6 minus 7x is equal to negative 6 root 6x. Make sure I subtracted correctly. Okay. All right, and then I'm going to divide by negative 6. draw a line here because I didn't leave myself enough room, right? So when I divide by -6, here I am. Now you can convert this to a fraction. I'm not gonna. I'm just gonna leave it like that and call it good. So here I'm going to go ahead and square to get rid of that radical. Ooh, this one's going to be ugly, y'all. And that's okay. We don't judge ugly answers. So here we have to actually square that top. So I have to go through another set of distribution. And that's fine. We love distribution by now, right? So I'm distributing the 6. Now I'm distributing the -7x. And I'm combining my like terms. And before you ask, yes, I did that with mental math. Oh, that's my alarm telling me to check my bread I have in the oven, y'all. While I'm writing this down, remember, always do something that makes you happy. Alright, -6 squared is 36, and on this side I have a 6x. Okay, yuck. But the good thing is we can get rid of that fraction. So I'm going to multiply both sides by 36. So, oops, not 3x, good lord. Now the thing is these are some pretty large numbers. When I go to multiply by that 36, I'm also going to write this top part in descending order. So I'm going to put the 49x squared first. Right? Because if we go to factor, which y'all know you want to factor, we need it to be in that counting order. Alright, so 36 times 6 is 216. Alright, now in order to use factoring, quadratic formula, whatever, we have to get this expression by itself here. So I'm going to subtract the 216x over. Okay, so I have 49x squared and 84 and 216 makes 300. So here's what I'm kind of guessing with this, because I know I'm probably going to have to factor it, but I'm seeing if it's factorable. Do you see how I have a perfect square here and a perfect square here, and this is addition? I have the feeling that this might be like a perfect square trinomial. And so what I'm doing is I'm kind of checking. So the square root of 49x squared is 7x. And the square root of 36 is 6. So if I take 300x and I divide it by 2, I get negative 150x. And I'm seeing if I multiply those together and then, no, they're not. Rats. Well, that's not a perfect square trinomial, so that is a mega bummer. Okay, so for this one, normally I factor and I'm like, ready to go, bye Felicia. But because my numbers are so big, this is kind of a bear to factor. So what I'm going to do instead is I'm going to use my quadratic formula. Alright, and that's kind of ugly, but there it is. And what I'm worried about is I'm worried that I'm going to run out of room. So what I'm going to do is I'm going to write C next, or next, you know, I don't know how to write, slide. And we're going to quadratic formula on the next slide. Alright, so Savvas is interesting in that they have to insert a slide. Spoiler alert, I'm doing the next example after this. Savvas is interesting in that you have to sometimes solve it in different ways, huh? So remember, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what I'm doing here. So I have x equals negative b, so I have a negative 300, so I'm just going to write a positive 300 here. And then b squared, so 300 squared minus 4 times 49 times 36 all over 2 times 49. Yuck. Okay. Hopefully this cleans up somewhere, because I don't really want to deal with that. Oh, that would be 98, not 96. Oops. So I'm just going to pull this radical to the side to deal with it. So I have the square root, 300 squared is 9 with 4 zeros, minus, so 4 times 49 times 36 is 7,056. So if I subtract that from 90,000, I get 82,944. Ooh. So now I'm going to take the square root of that just straight in my calculator, and that square root is actually 288. Oh. I forgot to put, or I didn't mean to put that square root actually on there, just the 288. Alright, so now let's actually split that. So 300 plus 288 is 588 divided by 98. And 300 minus 288 is 12? Probably 12. Let's see if 588 is divisible by 98. Not cleanly. Oh, that's because I didn't type in the calculator right. It is cleanly. It is divided by 6. And then here, well, 98 is even, so it's divisible by 2. We know that it's 49 times 2, so I'm going to call it 6/49ths here. And so those are my two solutions that I need to go back to the original and check. What I'm actually going to be doing on this one is I'm just going to go into into Desmos and use Desmos to check myself, only because I don't want to have a third slide of check steps, okay? Because that would be bananas. So when I go to type this into Savvas to check it out, notice that I'm not actually using a root. I'm actually just going to raise it to the 1/2 power. You can hunt down the root button, which isn't really that hard to find. You just click the keyboard. But I'm lazy, so there it is. Alright, so there is our graph. So notice the answer at 6 is there. So 6 is certainly the answer for part of it. But 6/94, which is less than 1, is not on that Desmos graph. So this one's going to be an extraneous solution. So x equals 6 is my only answer. So there we have it. That is solving an equation with two radicals. Until next time.